Hey guys, welcome to EduKaji. If you guys are first time here, allow me to introduce myself. So my name is Walter and I'm a chemistry tutor as well as a real life scientist. So this particular video will be discussing about a past trial paper for the SPM Chemistry syllabus. So without further ado, let's jump right into it.
Okay, so let's take a look at the MRSM paper. It's the same format, so nothing to worry about. Now, a very interesting thing about MRSM paper is that they like to ask more challenging questions. Okay, so if you can go through MRSM paper and survive it, then chemistry is good enough really for your confirm A. Okay, but I'm not saying it's very difficult for you. I'm just saying that it's more challenging. Some questions are actually some questions you won't be able to see in other places. All right, let's take a look at number one. Number one shows the ingredients of a cake. And we have the ingredients list. We have the wheat, flour, saturated fats, citric acid, corn syrup, caramel, lecithin, egg, and margarine. All right, okay. So again, we have the different ingredients listed inside for the cake. All right. One of the ingredients in the cake is fats. So state the physical state of fats at room temperature. So there are differences between fats and oil. All right, this is fats, not oil, so they're different. Okay, fat as in butter form . So the physical state of fats at room temperature should be solid . So that's the answer, solid. All right, unsaturated fats can be converted into saturated fats through reaction. Name the reaction. This is part of your organic chem . Okay, for you to convert any unsaturated molecule to saturated molecule, doesn't matter if fats or normal hydrocarbons, is actually hydrogenation. Okay, so you can either write hydrogenation or you can put there addition of hydrogen.
Citric acid commonly used in oily foods and cakes and biscuits as a food additives and function of the citric acid. So it is a food additive, and they want to ask you for the function of. They ask you a type of food additive and a function of citric acid. So citric acid is much like ascorbic acid as well. Okay, it's much like ascorbic acid, and ascorbic acid is vitamin C. So what they act as they're actually acting as an antioxidant. So you can put there citric acid, a type of antioxidant which prevents oxidation of food. Right, so that's the you can put slow down or prevents up to you. Okay, up to you. You can also put there prevents oil becoming more rancid. That could be also another function. Prevents oil from becoming rancid. Rancid as polymer cause of weird smell. Because of bacteria, something contaminated bacteria. Right, still an example of food additives to cake. So let's take a look at that. The food additive that you can see over here will still be lecithin, for example. Okay. So you can add as a thickener.
To aspirin. Aspirin is used to reduce fever and mild and moderate pain. Structural formula of aspirin is shown in diagram 2. All right, so state the meaning of molecular formula. So we did this before already, right? Molecular formula shows the actual formula. So put here a chemical formula. That shows actual number of atoms of each element in a compound. Okay, so write a molecular formula of aspirin. We calculate the number of carbon atoms, number of hydrogen atoms, and number of oxygen atoms. All right. The carbon atoms should be a total of 9, hydrogen is 8, and oxygen is 4. So then your molecular formula of aspirin will be C9, H8, and O4. The next is state the type of particle of aspirin. It's a molecule. Why? It's a covalent compound. is a simple covalent compound. So, the molecule. Okay, now let's move to the next one. The following chemical equation represents the burning of aluminum with oxygen. So when you burn aluminum with oxygen, you get aluminum oxide. Give two information that can be interpreted from the chemical equation above. This is actually more concept. So what happens here is that the first thing you have to know how to interpret this quantitatively and also qualitatively. Okay, when you talk about these two information, they actually want you to interpret the first one, which is qualitative interpretation, and the other one is quantitative. Right? What does that mean, right? So, for example, the first information that you can give in this equation above will be the reactants are aluminum and oxygen. Okay. The products are, the product is aluminum oxide. So that is technically qualitative. So if we interpret this qualitative, you get 1 mark. And then you have to interpret it quantitatively. How? You can say that 4 mole of aluminum reacts with 3 mole of oxygen molecule to produce 2 mole of aluminum oxide. So that is quantitative. So if you do both, you get 1 mark each. All right. So that's how you should. Whenever you see like easy ask you for two information that can be interpreted from chemical equations, and it's most likely these two, quantitative and qualitative. And then you get 2 marks really. Very simple. Qualitative means they ask you what is the reactants and products. All right. So how like this. Qualitative means state reactants, right? State the reactants and also products, right? And then quantitative means I'll say here talk about moles. For reactants to form products. So that's how we look at qualitative and quantitatively. Let's take a look at number 3. The M3 shows the standard representation of silicon. 28, 29, 30, all 14, 14, 14. So the top one will be the nuclear number, the bottom one will be proton number. What's the meaning of isotopes? So isotopes are atoms of the same element atoms of the same element with different number of neutron but same number of protons. Okay, meaning to say, you can also change the answer to nuclear number also. Different number, different nuclear numbers. Okay. Oh, you want to copy this? Okay. Okay. So as I was saying now, you can actually change the number of different number of neutrons to different nuclear number also. That is also accepted as an answer technically. Okay, so don't have to necessarily just use number of neutrons. You can also use nuclear number. And then they ask you to draw the atomic structure of silicon-28. All right, they ask you to draw the structure of silicon-28. So you have to make sure that you have to indicate the number of protons and neutrons also. So my advice is that if it's involving isotopes like this, what you can do is you can just draw, because you see here, right, it has 14, right? So the electron arrangement or the electron configuration will be 2, 8, and 4, right? Total 14. So to draw this, right, you make one big circle. Okay, this for the proton and the neutron number, proton and neutron number. And then the other 3 shells will be for electrons. Okay. Okay. So inside here, remember you have 14 protons and 14 neutrons. And outside here, you can just put crosses as an electron, no problem. All right, 2, 8, 4. Okay, done. I mean, it doesn't matter how you arrange the various electron, I can put together also if you want to, but I'm just putting it as separately, okay, just to make it nicer. So if you were to indicate the proton and neutrons, you get 1 mark. Correct arrangement with electrons, you get another mark. So total 2 marks here. Okay, this is for silicon-28. Right, so it's quite easy this so far, right? So no problem. Okay, now the next one will be a bit tougher. The percentage of natural abundance of silicon-28, silicon-29, and silicon-30 is 92%, 5%, and 3% respectively. Calculate the relative atomic mass of silicon. So they give you the hint or the information that you need, where silicon-28, silicon-29, and silicon-30 have different relative abundance, in which they have this percentage as a relative abundance. So how are we going to calculate the relative atomic mass? Relative atomic mass in this case is the average mass according to different isotopes based on their relative abundance. So the calculation is very simple. Relative atomic mass, I think I'll just put here. will be the nucleon number or the relative atomic mass of silicon-28 multiplied by the relative abundance. Okay, which means here 28 multiplied by 92 plus 29, which is the nucleon number of silicon-29 multiplied by its relative abundance, plus silicon-30. 30 is the relative atomic mass or the neutron number multiplied by its relative abundance. Okay, add all of them up together, divide by 100%. So if we do it correctly, you should be able to get 28 as the relative atomic mass. Isotopes are widely used in various fields. State one example of the isotope used in the medicine field. The easiest to use in medicine field, if you can, let's choose cobalt-60. Okay, why? The answer is very simple. Cobalt-60 is used, oh sorry, never mind, never ask you to use. Cobalt-60 used to treat cancer, that's it. Okay, cobalt-60 releases gamma rays. Gamma rays can destroy tumor or cancer cells. That's for number 4. Then 4 shows a part of the periodic table, PRSTUQ. All right, write the electron arrangement of ion T. I see, this is trying to trick you. Most of us ignore the fact that ion word is there. So we might miss that out. They don't want atom, they want ion T. So let's look at T first. T is a group 17 element and is located in period 3. Right? So if you ask me what's the electron arrangement of atom T, if you talk about atom T, it will be 287. 3 shells in total, right? Group 17, so 7 valence electron. So 287. But ion. So what happens is that atom T has only 1 more electron to achieve, it needs 1 more electron to achieve octet. So most likely there'll be 1 electron that will enter here, and then you will have a full outermost shell inside there. So therefore, the electron arrangement of ion T will be 288. Okay, again, ion. State the position of element S in the periodic table element. So S here will be group 16, period 2. So put here group 16, period 2. Right, arrange the atomic size of the elements in descending order. So descending order means from largest to smallest. All right. So remember, across the period, atomic radius decreases. Down the group, size increases. So I want to put here indicator for you. Down the group, atom size increases. Across the period, atom size decreases. So the largest atom, I would say, will be Q for sure. We start with Q, isn't it? So Q will start first. And then after that, we'll talk about this next one. Period 3. Period 3 got T and U. U comes after T, isn't it? So U has a smaller size than T. So after Q will be T, and then only U. All right. Then after that, you go to period 2. Period 2, you got what? You got S, R, and P. 3 different elements. What's it called? 3 different atoms. So we'll start with P because P is the largest. Going across the period becomes smaller, right? So P is the largest. So after that, U it is P, and then R, and then the smallest one among all will be S. So this will be your sequence. Okay. Which element exists as monoatomic gas? Only group 18 elements will exist as monatomic gas. So therefore, the answer is U. Okay, explain answer why. Because they have a stable electron arrangement already. Or you can also say they have already achieved octet electron arrangement. So you say here U has an octet electron arrangement. Elements P and Q located in the same group by different reactivity when react with oxygen. Explain why there is a difference in reactivity between these elements. So P and Q is where? P and Q is actually here, group 1 elements. Okay, group 1 element. So for group 1 element, right, you can say that going down the group, the atomic size increases. So the valence electron is located further away from the nucleus. So the attractive forces between the nucleus and the electrons become lesser. Okay. They ask you to explain the differences in reactivity only. Yeah. They didn't ask you which is more reactive or which is less. So we need to explain those. So you can just explain that size of Q, atom size, is larger compared to element P. Okay. Then after that, what I can say here will be the attractive forces between the nucleus and the valence electron is weaker in atom Q. That's it. You got 2 marks if you write that. Or you can also say that the atom Q can release electrons more easily. But I would suggest that you write about attractive forces because it makes more sense in that way. Okay, so you write here the attractive forces between the nucleus and the valence electron is weaker. Then you should be able to get 1 more mark already. So 2 different points, 2 marks in total. Okay, 5. Then 5.1 shows the structural formula of a polymer. So this is most likely an addition polymer because you see here, right? It's a carbon-carbon double bond there. Sorry, carbon-carbon over here. So what's meant by polymer? So a polymer is a long chain molecule or a long chain molecule that is made from a combination of many repeating molecules called monomers. So you say here a long chain, large product. Long sounds better. A long chain molecule made of combination of many repeating units of monomers. You can put in small molecules also. Okay, based on the F5.1, draw the structural formula of the monomer. So what happens here is very simple. Originally, before it opened up before it branches out, it's actually a double bond in between. So just draw back the same structure with a double bond between the carbon atoms. That's it. So therefore, I can just draw something like this. Now, in this case, you don't have. Sorry. In this case, you don't have to branch out the CH3 because they already give you the structure originally like that. See? So you don't have to draw it out. But of course, if you ask me, if you draw it out, is it wrong or is it correct? Yes, it's still correct technically. Okay, so which means you can draw either this or you want to draw something like this. Also acceptable. I'm giving you many scenarios here so you can compare. Because some of you might be wondering, like, oh, can I draw like that? Can I draw like that? Okay, up to you. Okay, this is the second structure. Or you can draw something like this as well. Basically, what I'm trying to say here is that you can move this around up to you. Okay, do you understand what I mean? And then if you want to branch it out, branch out the CH3 also can. Okay, so any one of those are acceptable. Okay, then name the type of polymerization reaction in the production of polymers. So like I said before, I got double bond means it's going to be addition polymerization. Right, state the use of the polymer. So this particular polymer, what we use it for is actually to make plastic bottles, if you want to. This is actually propene. Originally, it's propene, but you see, it's 3 carbon atom. Supposedly, hexapropyl is a 3 carbon atom alkene, right? So it's supposed to be propene. So when you form this, it's called polypropene or polypropylene. They are usually used to make plastic bottles or food containers. So you put here to make plastic bottles or containers. 5.2 shows a sports shoe used by a badminton player. So actually, there's a rubber sole here. So natural rubber and synthetic rubber can be used as materials for the sports shoe sole. Shoe stud rubber can be used as a material and justify a choice. So you remember badminton players when they play badminton, right? They actually move around the court a lot, so which means they actually, they strike left and strike right. And as they move left and right, when they step on the badminton court, they actually friction against the surface. So there'll be a lot of wear and tear, to be honest, when you play badminton. Okay. So if that's the case, then of course, if you use a natural rubber, it will definitely melt, or it will just wear off way faster compared to static rubber. However, you see, this one, right? It's entirely up to you, whichever you want to choose. They give you an option, so there's no right or wrong in this question. If you choose natural rubber, you just have to justify why. If you choose synthetic rubber, you just justify why. That's it. All right, it's up to you whichever you want to choose. So that's why I say justify your choice. All right, now let's just split it into 2 sections. Okay, so let's just say if you choose to pick natural rubber. Then you state why. If you choose synthetic rubber, also state why. There are pros and cons in both one actually. So it's up to you, So for example, in natural rubber, you can say soft law. Yeah, I write point form only, because I want to explain to you how it works. But don't write point form like you write properly in this section A. So you can say soft soft. Then explain It is easier how to explain this? Oh, softness, more comfortable for the feet. Okay. And then the other one will be low heat resistance. causes the sole to friction and melt slightly to prevent slips. Slip is in like, you know, you slippery surface. So when it's soft and it's low heat resistant, then you'll be able to become like, when it melts, when it friction, it melts, then it becomes slightly more sticky. You can actually cling it to the ground. That's just some justification from me. And then for the synthetic rubber, what happens, they can put there more elastic, so it's easier for you to retain the shape. Okay, so you can put here more elastic for synthetic rubber. Can be used for longer periods of time. Okay, and after that, another one will be high heat resistance. You put here shoe soles. Will last longer. Okay, so any point that you mention, I mean, technically, if you state that you want natural rubber, you want mark already. Okay, then explain two separate points, then you get another 3 marks. And you get another 2 marks, sorry. So therefore, you get 3 marks in total for this case. Okay, let's move on to the next one. Uncontrolled disposal of synthetic rubber leads to environmental pollution. Suggest one way to overcome this issue. So we can just say here, reuse or recycle. For example, you can say here, reuse the tires, reuse the rubber. To make to make sound weird. Reuse the rubber as reuse the rubber to pot plants or to grow plants as flower pots also can. So yeah, one of those examples will do. So 1 mark for you. Okay, number 6. Diagram 6 shows the electron arrangement of a compound formed from the reaction between X and Y. You can see they turn to ions, isn't it? So X and Y turn to ions. Write the electron arrangement of atom X. Now, you see this now is atom X. This is ion, this is atom X. So you see here 2 plus, right? 2 plus means it technically released out 2 electrons before that. So therefore, the electron arrangement of atom X before the reaction should be 2, 8, and 2. Okay, so you get 1 mark from there. Still a type of force of attraction between the particles in the compound. This one is, I mean, if you want to write ionic bonding, I don't think it's suitable. Okay, why? It says here the type of force of attraction. They didn't ask you the type of chemical bond between them. So if you write here ionic bond or ionic bonding is wrong. Okay, instead, ions of different charges, they have this force that attract them together. The force of attraction, what's it called? It's called electrostatic force. That's a more suitable answer. Okay, electrostatic force. So remember, do not write ionic bond. Okay, if they ask you about the force of attraction. If they ask you what kind of chemical bond or what bond exists between them, then of course lah, you put there ionic bonding lah. Okay, but because they ask you the type of force of attraction, not the chemical bonding, then you must write there electrostatic force. Write a balanced chemical equation for the formation of compound. Okay, now let's analyze a little bit. This one originally 282. This one originally 26. Do you see that? So if you think about it, right, this one total has 12 electrons, and this one has 6 electrons. If you refer this to the periodic table, right, it will have 12 protons, and this will have 6 protons. So choose and check and see whether it is what kind of element it has, what kind of element it is. So very obviously, this one here, X here should be magnesium, right? X should be magnesium, and this one should be oxygen. So that's supposed to be magnesium oxide lah. So since oxygen is a gas, is a molecule that exists as diatomic molecule. You understand? So you have to put Y2. Now you do not use Mg and O. Use back the alphabet they give you. In this case, we know that X is Mg, but just use X back. We know Y is supposed to be oxygen, but just use Y. So what I'm trying to say here is that you can just put here X plus Y2. You will get 2XY. Supposedly, if you refer back to the periodic table, then you can argue that, oh, this is magnesium oxide. Correct, but we don't know if it's magnesium or oxygen or not, ma. They give you X and Y. So you have no choice but to use back the alphabets technically. You understand? So remember, do not simply suka hati, go and write the main element inside. Just follow back the alphabet and you get marks. Okay, number 4, calculate the mass of the compound produced when 0.1 mole of X reacts to excess Y. Okay, now let's take a look at the compound produced. So we have 2X plus Y2 to get 2XY. So for every 2 mole of X, it gives you 2 mole of XY, right? Which means the 1-to-1 ratio lah. So right now, if you have 0.1 mole of X, you should also get 0.1 mole of XY. Okay, so molar mass of XY will be 24 plus 16, which is 40. So now, mass of XY produced is equivalent to 0.1 mole multiplied by 40 grams. So that would be 4 grams in total. Okay. So you must show your workings clearly in order for you to get 2 marks. 1 mark for showing working and 1 mark for the actual answer itself. Puan Juria puts a white solid in a cupboard to keep the cockroach away. The physical properties of a white solid is as follows: cannot conduct electricity, right, in any states, and it has low melting and boiling points. So to keep this cockroach away is most likely naphthalene lah, okay, mothball. Based on information, identify the type of compound of the white solid and explain each properties. So first of all, they want you to explain the type of compound. So see, when they ask you about type of compound, means you must state lah, covalent compound, no? Okay, so you say that it is a covalent compound. Okay, and then why it cannot conduct electricity in any states? So you say over here lah, the substance consists of neutral molecules okay, neutral molecules that does not that do not have free moving ions to carry electrical charges. Okay, that explains the first point already. So you got 1 mark over here. Next one, you explain also why as we have low melting and boiling point. So you say over here, the substance are the molecules, sorry, the molecules of this substance is held by weak intermolecular forces. You can choose to put van der Waals if you want to, no problem. Huh? Okay. So you say here weak intermolecular forces that are easily broken. So if you want to explain that, you can get 1 more mark from there.
Okay, so we have diagram from example 1 shows the energy level diagram of the precipitation of barium sulfate BaSO4. We have the X plus K2SO4, you get BaSO4 plus Y. And the delta H value is negative 1,473.2 kilojoules per mole. And then they ask you the first question, A1 over here. What is the heat? What's the meaning of the heat of precipitation? So heat of precipitation is the heat change when 1 mole of precipitate is formed from their ions in aqueous solution. Okay, so you can put here heat change. The reason why I put heat change because sometimes it can be endothermic, it can be exothermic. Huh? So here we say heat change when 1 mole of precipitate is formed from its ions in an aqueous solution. It's a very specific definition. Okay, and of course you need to have all the keywords in point, right? So you can see here heat change 1 mole. 1 mole is important. Huh? 1 mole of precipitate. So the heat change, 1 mole of precipitate being formed from its ions, okay, which is in this case barium and sulfate ions in an aqueous solution. Why must be in aqueous solution? Because only in the aqueous solution the ions will be able to meet each other, right? The ions will be able to dissociate out in water, and then you'll be able to form this precipitate. Okay, you cannot form on air because then there'll be no ions present. All right, then A2 here, state more information that can be obtained from the energy level diagram shown in 7.1. Okay, so one of the things that we can see in this energy level diagram is the heat of precipitation. Okay, so the heat of precipitation is 1,473.2 kilojoules per mole. So what you can say here is you can either write this down, okay? You can say that 1 mole of barium sulfate form will release this much of energy. Or another thing is because it's negative, right? You can also say that this is generally a exothermic reaction, also correct. So it depends on whether you want it to be more complicated or easy. If you want the easy way out, then of course you just write the exothermic reaction. Okay? So based on the diagram, right, you can say that this is an exothermic reaction. Name solution X. So you should technically know that it is of of barium. Right? X must contain barium. And it can be any barium salt which is soluble, right? If you're asking, if they're asking you to give a suggestion, the best will be, I would say barium nitrate, right? Because all nitrates are soluble. So you can name here barium nitrate. Now, is there any other barium salt which is soluble? Yes, you can also write here barium chloride. So barium chloride is also soluble. Only barium sulfate is insoluble. So for X, you can either write barium nitrate, or you can also write barium chloride. Base your answer in 7A3, write the ionic equation. So if you choose barium nitrate, okay, or if you choose barium chloride, it doesn't matter. Why? Because at the end of the day, the precipitate that's being formed is BaSO4. So question number 4 here is actually there to confuse you. Because some people say, oh, ionic equation of what? Is it of the barium nitrate? Because you say based on 7A3, right? Is it based on barium nitrate and barium chloride, or is it the reaction itself? They actually said it's for this reaction. So it must be the precipitation. So therefore, the ionic equation here is for the precipitation, which is Ba2 plus SO4 2 minus, and you'll be able to get BaSO4. So that's your ionic equation. B1, right? The thermochemical equation below represents the reaction between lead-2 nitrate solution and sodium sulfate solution. So you have PbNO3 with Na2SO4. You get PbSO4, NaNO3, and then the delta H value is minus 50.4 kilojoules per mole. So it says here, calculate the increase in temperature when 25 cm cube of 1 mole per dm cube of lead-2 nitrate is added to 25 cm cube of 1 mole per dm cube of sodium sulfate solution. Yeah, as usual. So now what they do is that they give you the delta H value, you do reverse it and find out what theta is. Okay, so again, we're gonna use two different formula. We'll start with the first one, which is delta H. It's equivalent to Q over N. But since our focus is on theta itself, so we'll make Q as a subject because the delta H is already known. So Q right now will be delta H multiplied by a number of moles. Okay. And since the delta H over here is 50.4 kilojoules, again, no need to put a negative there. So now multiply by N. All right, now, because right now we see, right, the number of mole is 1 mole per dm cube for both solution, and the volume is also the same. So to calculate N is very simple. N, which is number of mole, you can calculate it with MV over 1000. So that would be 1 times 25 divided by 1000. Should be able to get 0.025. Yeah, so the answer is 0.025 mole. So here it will be 0.025 mole multiplied by the kilojoules, and let's see how much we get. So we get 1.26 kilojoules per mole, right? So right now what happens is that we're going to convert this to what's it called? Sorry, this is kilojoules, right? So we're going to convert it to joules first because initially the first part of the formula we use joules. So multiply by 1000, you get 1260 joules of energy. You see that? So after what happens is that we're going to use the second formula, which is Q is equivalent to MC theta, making theta as a subject because we want to calculate what's temperature change. So that becomes theta is equivalent to Q divided by MC. Now, Q we have already 1260 joules. M itself will be 25 plus 25, so it's 50, and C is already given. So this is very simple, substitute the value in. So that'll be 1260 divided by 100 times 4.2. Right. So it's 50. It's 50. Right. Because now you want to reduce half the temperature. This is for those of you who are still confused. Okay. What this question is trying to say is very simple. Okay. It says here, I want to get back the same amount of energy release, but somehow my temperature change is half. So from 6 degrees Celsius, it becomes 3. So if its temperature is half already, how else can we actually increase another factor so that we can get back the same amount of heat being released? So what we saw just now is, in this case, I say because they said you cannot change the volume, right? One thing you cannot change is the volume, because it says here same volume of solution. So the only thing that's affecting the heat release right now is what? What's the thing that's affecting the heat release right now after the temperature being changed already? How do you get back the same heat if technically your temperature is reduced? You can actually try to adjust the concentration. You cannot change the volume, but the thing that you can change over here now will be your concentration. You understand what I mean? No? Okay. So if you halve the temperature, what else do you have just to get back the same amount of heat release? Anyone? Assuming that the volume is the same. Very good. Correct. So Jared got it ready. You're supposed to halve the concentration. Why? Because if you halve the concentration, the factor all become the same back again. Because if you calculate back again, right, if you use 0.5 mole for each substance, you can actually get back the same amount of heat being released. Correct. Okay, yeah? Now you ask yourself, if this question very hard to solve, right? If some of you say this is very hard to solve, then you ask yourself, what formula do you use to calculate heat of heat release? Okay, so your Q is equivalent to MC theta. And then you got delta H is equivalent to Q over N. Right? You cannot change the volume. Therefore, mass cannot be changed. You cannot change the C also, because the C is a constant. And you cannot change this one. You cannot change the temperature because it already says it reduces by half already. So now you ask yourself, what else can you change? You can't change the Q because the Q is dependent on all these factors. So which comes back to the same point. The only thing you can change now is the N. Right? So if the N is the only factor you can change here, what affects the N? Concentration. You understand? So in order for you to get back the same value, because you have half the theta already, isn't it? What you can do is you can also halve the concentration of both solutions. Okay. So the answer here will be use 0.5 mole per dm cube of both solutions. My explanation earlier just now was a bit confusing. I apologize. I was actually trying to hint you to think about the number of moles. So from the number of moles, which is N over here, then you'll be able to guess and say, I must change the concentration. But maybe the way I explained is a bit confusing for you, so that's why you didn't understand at first. All right, anyone still confused now? Or anyone understand what I'm trying to say over here? It's basically playing with math, It's just math. So if you're good in math, you can actually understand this quite easily. If not, then you have to look in a different perspective. It's something like ratios, correct? If you halve a certain factor to get back the same value, you have to halve other factors as well, right? Or if you still don't understand that, I can give you a very simple example. Okay, right now you don't want to make 10 cupcakes, you want to make 5 cupcakes. Okay, but the size of the cupcake remains the same. So what do? You halve the ingredients. You get what I mean? I'm trying to make it very easy for you to understand. All right. It's like, for example, you want to make the recipe is for 10 cupcakes, but you don't want to make so many cupcakes because you can't finish. So you want to make 5 cupcakes only. But the size of the cupcakes cannot be adjusted. So what do? You halve the ingredients. That's it. Table 7 shows the fuel of methane and octane. So we have methane, which is 27 kilojoules per gram. Octane is 89 kilojoules per gram. Boiling point of methane will be minus 161.6. Octane is 125.6. Physical state at room temperature will be gas for methane and liquid for octane. Price per liter for methane is 2.05. octane is 4.84. Which fuel will you choose for cooking? Justify your choice. Now, this is a not so popular question because this is more towards like, thinking. You have to apply it. All right. Now, again, there is no right or wrong in this question. Meaning to say, right, because this is based on your choice, you choose. So it's very subjective. You cannot say I'm wrong, it's my choice. It's that I ask you to choose between apple and oranges. Some of you might like oranges, some of you might like apples. Right? So there's a choice there. You can choose it for yourself. The problem now is that you have to justify your choice. But justification here is based on your knowledge in chemistry, not simply based on general knowledge. So for example, right now, right, I will give you two scenarios, okay? Assuming that right now we choose methane, all of us favor methane. So we ask ourselves why, okay? It doesn't matter if you choose methane or not, okay? Your selection will automatically give you 1 mark already. So which means die also got 1 mark already, unless you don't write anything on top. So you can write methane, you get 1 mark, you write octane, so you get 1 mark. The question now is how you justify it. Okay, now, for methane, if you want to justify, you justify the price. You understand? You justify the price. It's cheaper compared to using octane because this is based on per gram of energy release. Okay? Now, if you were to choose octane, also correct. But how do you justify it? The amount of energy release compared to methane. So either you take methane and you justify the price, or you pick octane and you justify the energy use, or the energy amount is higher. Then you should be able to get 2 marks. It's actually quite easy. Okay? So scenario number 1 will be methane because it is cheaper. Compared to octane. And then if we choose octane, can also because it has a higher energy value. Okay, so for question number 8 will be diagram 8 shows the electrolysis, right, of sodium chloride solution and sodium nitrate NaNO3 solution using carbon electrodes. Okay, now the one thing that you realize over here is that you're using 1 mole per dm cube. If you recall back what I explained to you before in your Form 4, for those who joined my class, of course, I actually told you guys before that as long as it is 1 mole per dm cube and higher or above, it's considered as concentrated solution. If it's diluted, it's usually 0.5 and below. Then that's how we see it. If not, then sometimes they will mention to you that, okay, this is a concentrated solution or this is a diluted solution. Then you'll make your life much easier. But let's just say in this case, you see now, right, they didn't say what is the whether it is diluted or concentrated. They get confused, right? You say, oh my God, what is this? Is this concentrated or is this diluted? Because 1 seems very sus. But the answer is concentrated because I say 1 and above considered as concentrated already. So your substance to be discharged is based on concentrated solution. Okay, so you have 1 mole per dm cube of sodium chloride, and you have 1 mole per dm cube of sodium nitrate also. So then you have your standard electropotential value of the substance. So whatever that you explain in this whole question number 8 must be based on the standard electropotential values, not based on the ECS that I always mention anymore. Why? Because they didn't mention that it's ECS and it specifically give you this values. So you must use the values over here to justify why certain substances are discharged and so on. So based on cell number 1, which is the left one, sodium chloride, state all anions present. Anions refers to negatively charged ion. So you have OH minus and Cl minus ions. Okay. Now, they didn't say name. So you are able to write the symbol, the formula of the substance. If they say name, you must name. You see next question, number 2, name the product formed at electrode P. So you cannot put there Cl2. You have to put there chlorine. They say name, you must write out the full name itself. Okay? Now, how do we know if electrode P, supposedly electrode P is the anode and Q is the cathode lah. So how do we know if P is actually chlorine? So you see, at the anode, you have OH minus and Cl minus. When I explained to you last time in Redox, right? Whatever that's more concentrated, if there is the word concentrated or if this is a concentrated solution, we only look at the anode for the substance to be discharged. The cathode automatically follow ECS, very easy one. The lower the better. But this case right now is concentrated and anion now got 2 different ions. So the one question you must ask yourself is, do we see a halogen there? Yes, we do. If you see the halogen, we pick the halogen straight away. So your half equation for that will be 2Cl minus becoming Cl2, releasing 2 electrons. This is how we do it. So you know that chlorine gas is being produced. So that's why at P, chlorine gas is the substance to be discharged. Okay, very simple. Now explain your answer now. Whenever I ask you to explain your answer, right, this is the tricky part. You guys will know what will be discharged. But to ask you to explain, sometimes you get confused. Now, in this particular question, right, you cannot explain in terms of this one. Cannot. Why? Because it is not about the position anymore. It's about the concentration of halide ions. So if you want to explain this one, actually, it is acceptable. It is acceptable based on the marking scheme. However, most students will choose the easy way out. If it's a concentrated solution, there is a way to write an easy answer for this. Because concentrated solution means you have more of that specific ion. It only works for the anode, however, it cannot work for the cathode. So for the anode part, if it's concentrated and you have a halide ion, you can put there are more chloride ions compared to hydroxide ions. Then you want mark already straight away. Okay, so which means you can put there chloride ions. Okay, sorry. Concentration of chloride ions is higher compared to OH minus ions. Number 4, describe a chemical test to verify the product formed at P electrode. So same thing, you are trying to identify what's it called, chlorine gas. The easiest way to test for chlorine gas is just to use a blue litmus paper because chlorine gas is acidic, right? So you can just put there moist blue litmus paper, turns blue, turns red, and then bleaches it. That's it. So you say chlorine gas can be tested using a moist blue litmus paper. The litmus paper turns red. Then bleaches it. Now, next, write a half equation at R electrode in cell 2. So electrode R will also be anode. Now you see, right now the anode has 2 different ions. We have OH minus and we have NO3 minus also. So since R is the anode, these 2 ions will be attracted towards it. But even though this is concentrated, you see, right? It is the same concentration, 1 mole per dm3, isn't it? But nitrate will never be discharged. Same goes for sulfate. So in this case, if you ask yourself, I don't see a halide ion, although it is concentrated, then automatically you'll pick hydroxide as the substance to be discharged. Only when there's halide, for example, like chlorine, bromine, and iodine, for example, then you choose those for discharge. Otherwise, no. So mean to say, for B right now, hydroxide is being discharged, although it is a concentrated salt solution. So the half equation over here will be 4OH minus, you get O2 plus 2H2O plus 4 electrons being released. All right, table A shows an experiment that investigate the displacement of metals. So we have one which is lead-2 nitrate solution, and then there's iron, and then we have another one which is lead-2 nitrate with copper. So for the first experiment, a gray solid is formed. Second one, no changes. So compare and explain the difference in the observation. So the reason why you can see a reaction on the left side, which is the first experiment, is because iron is more reactive than lead, based on the reactivity series. So iron can displace lead from its own solution. However, copper cannot, because copper is actually less electropositive and also less reactive compared to lead. So it won't be able to displace lead out from its own salt solution. Okay. So what you can say here is very simple. You can just say that you can explain what you can see first lah. All right, explain the observation. So we say that the first one, the inference is that lead metal is formed, right? In observation 1, lead metal is formed, but in test tube 2, no reaction occurs. So you put that in test tube 1. Lead metal is formed. But no reaction in test tube 2. So this is not observation, huh? This is inference. Okay, we're writing inference right now. Why? Because observation is already given to you. So you're not writing observation, you're writing an inference. So in test tube 1, we said that we infer that lead metal is formed. That's the gray color solid. And then no reaction in test tube 1, which is indicated as no reaction just now. Okay, so then after that, you must explain why. Okay, I will say that lead is displaced by iron because iron is more reactive than lead. So you say here lead is displaced by its own salt solution. Displaced by iron. From its own salt solution. Because iron is more reactive compared to lead. And then explain also why the other one cannot. Then you say that copper is less reactive than lead. It cannot displace lead. Okay, all right. So based on your answer in 8C1, suggest an action to be taken to ensure reaction occurs in test tube 2. So what can you modify, or what can you do to make sure that there will be a reaction in test tube 2? So if you want to see a reaction, you can change experiment 2 setup or test number 2, change lead nitrate to silver nitrate, and there will be a reaction already because copper is more reactive than silver. Okay, so the first answer you can give will be change PbNO3 to solution to AgNO3. Done. Okay, so the answer is very simple. You can also change copper wire to zinc, to magnesium, okay, to aluminum, less reactive ones. So you can change 2 things over here just to see a chemical reaction going on. So anyone will do. So section B. So answer 1 question in this section, but let's discuss all. Diagram 9.1 shows a conversation between a patient and with a stomach ache and a doctor. So we have Dr. Gee. You can eat this antacid tablet to relieve your stomach ache. This tablet can be swallowed directly or chewed. Then the patient say, yes, Dr. Gee. What a good patient. They will ask question. Based on diagram 9.1, which method will relieve the stomach pain faster? Explain your answer. All right, this is not so much of medication, but rate of reaction. You see, right? They actually mentioned very specifically, it can be swallowed directly or chewed. So when you have, if you swallow it directly, it's a whole tablet. So it takes a longer time for it to dissolve into the acid. The idea of eating antacid, antacid is actually an alkaline substance or calcium carbonate, which can actually help to neutralize the acidity of the stomach. Right? It's actually used to relieve gastric pain. Okay. So obviously, if we say, of course, we will choose the correct answer, which is to chew it. Okay. Why? Because chewing the antacid tablet will break the tablet down into smaller pieces. And that actually allows the stomach acid to react with the antacid tablets more quickly because it has a larger total surface area. So the answer is very simple. Chewing, you see that? Chewing the tablet is a better choice, or it's more effective. They explain why, because you see, chewing the tablet breaks it into smaller pieces. Okay. Then you say that this creates a larger surface area. For the antacid to react with the stomach acid. Okay, so you got 3 marks. Okay, all right. Then after that, we can see here number 2. The antacid tablets contains calcium carbonate. Table 9 shows the volume of gas collected against time for the reaction between antacid tablets with hydrochloric acid. So set 1 and set 2 uses different size of antacid tablets. So the first one you can see here, the gas collected for experiment 1 is 0, 31, 48, 48, 48. And then the other one will be 0, 38, 54, 67, 72, 72. Right, so which means the volume of gas collected for experiment 1 is lesser compared to experiment 2. Okay, so calculate the average rate of reaction for set 1 and set 2. So the rate for set 1 will be, so the maximum volume of gas collected is 48, right? And it takes about 2 seconds. Sorry, 2 minutes. Right, maximum 48, 2 minutes. So you want to calculate the what's it called? The rate of reaction by minutes also can, by second also can, because why? They didn't say what they want, so you can just calculate either one lah. But I'm going to make it into 120 seconds lah, because I want to do it in seconds. So therefore, rate of reaction for the first set will be 48 cm cubed divided by 120 seconds. So that'll be 0.4 cm cubed per second. Okay, but again, it's up to you. If you want to do it in minute, also can. So if it's in minute, means it's going to be 48 divided by 2, which is technically 24 cm cubed per minute. All right. And then for set number 2, if you want to convert it, also can. The one also can. So that'll be 72 cm cubed divided by a total time of 4 minutes. So 4 minutes, 60 seconds. So 240. So 72 divided by 240 will give you 0.3 cm cubed per second. Or if not, it'll be 72 divided by 4. That will be 18 cm cubed per minute. Okay, all right. Now write a balanced chemical equation to represent the reaction between antacid and HCl, and then calculate the mass of calcium carbonate in the antacid tablet in the set 2. Okay, now let's see. So the chemical equation here is very simple. We have CaCO3 plus 2HCl. You'll be able to get CaCl2 plus CO2 plus H2O. All right. So what happened here is for set number 2, right? Is this? Okay, so for set number 2, the maximum volume of gas released is 72 cm cubed, right? That's the end of the reaction. So right now, the amount of CO2 produced will be 72 cm cubed, which I'm going to convert it into dm cube first, because I want to calculate the number of moles. So divide by 1000, you'll get 0.072 decimeter cube. Okay, so to get the number of mole of CO2, you'll take the number of the volume of gas, divide by its molar volume at RTP. Then let's see how much that is. So number of mole is 0.003 mole of gas, right? So you can see here the ratio of CaCO3 to CO2 is 1:1. All right, so therefore number of mole of calcium carbonate will also be 0.003 mole. To get the mass, right, to get the mass of calcium carbonate needed to release the amount of gas, you have to calculate the number of moles multiplied by this molar mass. So let's calculate molar mass and see, okay? So molar mass or the relative formula mass of calcium carbonate will be 40 plus 12 plus 3 times 16. Supposed to be 100 lah, as far as I remember. But I don't trust myself, so let me just going to calculate myself again one more time. Yep, correct, 100. Okay, so mass of CaCO3 is 0.003 mole multiplied by 100 grams. You get 0.3 grams. So the antacid tablet that the person ate is 0.3 grams. Diagram 9.2 shows the graph of volume of gas released against time for 3 sets of experiments to investigate the factors affecting rate of reaction between zinc and nitric acid. So we have 3, 2, 3, 1, and 2 lah. So excess zinc powder is added to 25 cm cube of 0.2 mole per dm cube of nitric acid at 30 degrees Celsius in set 1. Suggests changes that can be done to set 1 other than concentration of nitric acid and temperature to obtain the curve as shown in set 2 and set 3. Explain both your suggestion based on collision theory. Okay, very simple. Okay, just to break down what this question is trying to say, yeah. Right, it says here that you add excess zinc powder into this nitric acid, okay, at 30 degrees Celsius. They ask you to change something about set 1, right, other than the concentration and also temperature, so that you'll be able to get a higher rate of reaction, which is set, which is 2, okay, either higher or lower, okay. So set 2 is lower, set 3 is high rate of reaction. Okay, now bear in mind, you cannot change the concentration or the temperature. So to get set 3, what you can do is you can add a catalyst. Because by adding catalyst, you'll be able to get a higher rate of reaction. To get a lower rate of reaction, what can you do then? You can change the size of zinc. Meaning to say, this one, number 1 is powder, right? You can now use one. Number 2, you can use zinc granules or zinc chips or zinc lumps, up to you lah. As long as you can mention anything else other than the powder form, you should be able to get a lower rate of reaction. Okay, for the reaction between zinc and hydrochloric acid, you can add a catalyst, which is copper 2 sulfate. This one can actually work. You can add copper 2 sulfate inside to increase the rate of reaction. You have seen this before in the previous question just now. All right, there's one experiment that we discussed earlier. They have this particular example. Was it this one? There's one with the rate of reaction. Or maybe it wasn't with you, sorry, it was with my Form 4 students earlier. Never mind, it's with my Form 4 students earlier. So there was one question also similar. They asked to how can increase the rate of reaction. So the catalyst that they used was actually copper 2 sulfate. So you can either add catalyst or you can change it to zinc granules to get different outcomes. Now, they say explain both your suggestions based on collision theory, and then got 10 marks in total some more. So what we're going to do is we're going to write it in a separate paper, okay? Okay, to obtain a graph of set 2, you can say what a catalyst. Okay, a catalyst can be added into the reaction mixture. Okay, then after I explain to obtain graph 3 or graph of set 3, a larger piece or larger pieces of zinc metal can be added into the acid. When a catalyst such as copper to sulfate is added into the reaction mixture, it can increase the rate of reaction. Okay, now how does it do it, right? So the question is, so right now when you say that you add copper to sulfate inside, it can increase the rate of reaction, you get 1 mark already. That explain in terms of how it works. Okay, so you say that a catalyst can provide the reaction with an alternative pathway of a lower activation energy, right? Then you say that this can increase the number of effective collisions that's enough already. So 2 marks on top. Let me just give you the mark distribution. So here we have 2 marks already. Got 2 suggestions. Then this one over here got 2 marks, 1 mark, 1 mark. So which means this one is set 3 actually. And this is set 2. Okay, let's change the number again already. Okay, then after that, okay, continue on with the set 2 that technically, right? So you say here set 2 in set 2 when the size of zinc metal used is increased, the total surface area for the acid to react decreases. All right, then I explain this decreases the number of collisions between the reactant particles, okay, which will lead to a decrease in the number of effective collisions. Therefore, the rate of reaction decreases. Okay, so should be able to give you a total of 4 marks here. So what happens here is the first mark it will be given to you when you describe the total surface area decreases. Okay, and then you also mentioned the number of collision will decrease. Okay, so this will give you another 1 mark. And then you also state as a decrease in number of effective collisions, which will give you another 1 mark. And mentioning that the rate of reaction will drop will give you another 1 mark. So we calculate all together, you should be able to get 10 marks in total. Right? 10.1 shows the process used to separate petroleum into various products in the industry. So this is actually called fractional distillation. So you say here, state the method and the physical properties involved in the separation of petroleum. So I already give you the method already. The method is called fractional distillation. All right. The physical property involved here will be based on its boiling point. Okay. So you say here, the physical properties will be melting and boiling point. Two,2,4 trimethyl pentane and butane are products of petroleum distillate. Draw the structural formula of the distillate. So let's try 2,2,4 trimethyl pentane. So we'll draw pentane first because that's the main structure, right? So pentane has technically 5 carbon atoms. And since it's a 2,2,4, it'll be 1 here, 1 here, and 1 here with no particular order. Okay, it's up to you where you want to put it, but it must be the second carbon atom. So it will be CH3. I have no space, but you please draw full. Okay, and then another one over here, which is also CH3. And then on top here, it will be CH3. And then the rest of it just fill up with hydrogen. So you've got 2,2,4 trimethyl pentane. Very simple. So if you were to number the carbon atom, it will be 1, 2, 3, 4, and 5. Let me see if the marking scheme allows you to put the condensed structure. Oh, they do. So, but still, I encourage you to draw it full, okay? And then another one will be, what else? Butane. Butane, very easy, just 4 carbon atom and fill up the rest with hydrogen. That's it. Draw both correctly, you get 2 marks. Okay, naphtha is a mixture of hydrocarbon that consists of 5 to 10 carbon atoms. One of the distilled product is hexane. Right? Write a chemical equation for the combustion of hexane. Calculate the volume of carbon dioxide gas released at room conditions when 258 grams of hexane is used in the complete combustion above. Okay, let's write the what's it called? The balanced chemical equation first now. Okay. So the formula for hexane is C6H14 as usual plus O2. Okay, now it's a complete combustion supposedly. So what you can do is, okay, technically you should have 6 moles of carbon dioxide because following this one, right? And then you put there 7H2O. Supposedly okay, but you realize it's a odd number. If it's odd number, means you have no choice but to put a fraction on your oxygen, which you don't want. Okay, so what do? We times 2 the whole thing, easier. So if we times 2 the whole thing, then it will be 19 O2, 12 CO2, and 14 O2. Correct, my maths. Jump wrong here. 19 times 2 is 19. So 14 plus 24 is how much? 38. 38 divided by 2, 19, correct? Oh, very complicated, but it's okay. All right, now I usually don't encourage you to put fraction. I can just try to make it into a whole number, so times 2. All right, now we're going to calculate the molar mass of hexane. So the molar mass of hexane will be 6 times 12 plus 14. So it's going to be 86. So number of mole of hexane will be 258 divided by 86. So it's 3. So 3 mole of hexane is present. So this will be 3 mole, and this will be, this is a ratio of 2 to 12. So I'll say 1 to 6. 1 to 6. So if it's 3 means triple, 18 times carbon dioxide, correct? 3 mole of hexane to 18 moles of carbon dioxide. So if it's 18 moles of carbon dioxide, then what's the volume? 18 times, this is 3, here is 1 to 6, right? 2 to 12 is 1 to 6. So 3 times more, correct? Correct, okay. So 18 times 24, 432 dm cube. Okay, so mean to say 18 mole multiplied by 24 dm cube, the total volume of carbon dioxide gas produced is 432 dm cube in total. Done. So balancing chemical equation, 2 marks. Calculation plus final answer, 3 marks. Okay. So for the percentage of carbon in Q is higher than R, so that means there's more carbon, right, per unit molecule compared to R itself. So using this justification, when you calculate it in terms of percentage of carbon, you can actually prove that because Q, being an alkene, has a higher percentage of carbon, when you burn alkenes compared to the corresponding alkanes, you actually get more soot for Q compared to R. So that's your explanation. That's your justification, actually. Okay. So you can say here, Q burns with more soot than R because the percentage of carbon in Q is higher than R. Then with the explanation and with the calculation, you should be able to get full marks for the explanation already. Okay, so write this down first, and then we'll move on to the other example, just to give you an idea of how it looks like. So in terms of the explanation for the other example, which is if you were to change it to propane and propene, right? Same thing, just that the calculation and the percentage should be slightly different. So let's just say, for example, number 2. So example 2 means you're using Q, which is C3H6, and R will be C3H8. So again, for Q, mass of carbon okay. So more carbon, then of course more smoke or more soot can be produced, because sometimes due to incomplete combustion, like a lack of oxygen, carbon deposit we produce, right? You all remember, right? There's actually complete combustion and incomplete combustion. So for the incomplete combustion process, there's 2 products that can be formed. Number 1 is carbon monoxide, which you all know already. All right, it's a toxic gas that can actually cause death if it's inhaled too much, and also carbon, right? Sometimes lack of oxygen can also produce carbon, just pure carbon by itself. So the soot that is produced, the black color stuff that comes out from the flame, is actually carbon. Okay, so of course, the higher the percentage of carbon means there's a higher chance of getting soot being produced if there's a lack of oxygen. Of course, if it's plentiful of oxygen, then there won't be any problem. There won't be as much soot as when there's a lack of oxygen. However, when we have more carbon atoms per molecule, it is actually very possible that there will be more soot being produced compared to the one that has lesser amount of carbon per molecule. So that's the explanation. Okay, so mass of carbon will be 3 times 12. Let me put bracket here, sorry. So that would be 36. And after that, mass of Q will be 3 times 12 plus 6 times 1. So that's how much is that? So that would be 36 plus 6, 42. So the percentage of carbon in Q will be 36 divided by 42 multiplied by 100. You get 85.71, which is the same thing as earlier. And then at the same time, for R, mass of carbon will be the same thing. The mass of R okay, so 36 it'll be 81.81%. Okay, so again, using the same comparison, you can see that in Q, there's a higher percentage of carbon atom per molecule compared to R itself. One is 85.7%, and then one is 81.81%. So you can either use 3 carbon atoms, alkene and alkene, to calculate the values, or for this part here, you can just use the 2 carbon alkene and alkenes to calculate them. Either way, you'll still be able to get the same answer. The explanation is the same, right? The reason why Q can burn in more soot compared to R is the fact that it can actually, they have higher percentage of carbon, and this higher percentage of carbon leads to more sooty flame when being burnt. Okay, so this is just an explanation lah. You have to write down the calculation to get the marks necessary to justify the sootiness of the flame. That's why we see just now earlier, right? The part that we discussed just now is actually 4 marks in total. Okay, if you were to just in your mind right now, just mention the fact that Q has a higher percentage of carbon compared to R, but you don't justify it using calculation, you don't get 2 marks. They will deduct 2 marks from you, which means you said that Q is more the flame of Q has more soot than R because Q has a higher percentage of carbon. That's it. You stop there. You didn't show the calculation or not, then you just say that. So then you only get 2 marks. You don't get another 2 extra marks from the calculation itself. So you must be able to write down the justification and to prove to them that it is indeed Q has higher percentage of carbon, you need to show the calculation. Okay, unless this question is worth 2 marks only, then no need. But because this question has 4 marks in total, then you must be wondering, okay, where does the extra mark comes from? It's from the calculation. That's why they actually give you the relative masses. Or else they wouldn't bother to give you relative masses at all if they don't want you to calculate. Okay, so I hope that will answer the question that you asked just now. Okay, for D, diagram 10.3 shows the freshly plucked local fruits. Okay, this is tropical fruits, I guess. All right, it's pineapple, watermelon, oranges, banana, and kiwi, whatever. They say over here, ethene gas is naturally released from the ripe fruits. Some fruits are infected with artificial ethene during the ripening process. Justify the use of artificial ethene during the fruit ripening process. So this is more or less like a K-BUT question. Okay, it's telling you that fruits generally produce ethene. Ethene is a gas. To plants, they're like hormones to be able to stimulate the ripening process of fruits. Okay, but some farmers, they don't actually wait for the fruits to produce the gas by itself. Instead, they will sort of like inject or to release the gas artificially into fruits so that they can ripe faster, supposedly. Okay, so they're asking you, why? Why do we actually use artificial ethene to cause the fruit to ripe faster compared to just letting be, like normal, for example? So in this case, a lot of you might be a bit confused, like, okay, how am I supposed to justify it? Now, justification here means, you see, recently, a lot of trend. If you notice, there's a lot of trend of this justifying questions. Okay, they'll come with the word justify. So whenever you see this word justify, right, you should relax a little bit. Why? Because it's an opinion-based question. Whenever there's an opinion-based question means, right, you get to choose your answer, either yes or no, agree or disagree. So there's no right or wrong one, which means automatically you get 1 mark already. You say yes, 1 mark. You say no, also 1 mark. It doesn't matter. There's no right or wrong here. But the other 2 marks, right, comes from justification. It comes from explaining why you agree or you disagree. Explaining why you choose option A over option B. And that's the harder part. So the easy part is now it's asking you whether you should agree or disagree. Okay, so it's up to you. Actually, you want to agree or disagree, it's up to you. So right now, let's just say I agree. Okay, let's just say I'm the person who agree that farmers should use artificial ethene to cause the fruit to ripe faster. Okay, so we'll start with the agreed part. It depends on you, it's up to you actually. Some of you may disagree. So let's just say for those of you who say I agree, 1 mark already. Okay, just write agree, you can use it, 1 mark already. So why do we want to cause the fruit to ripen faster or to ripe faster? Anyone? Why do I choose, or why do farmers choose to use artificial ethene to cause the fruit to ripe faster? Imagine you are a farmer right now, okay? And I come and promote to you and say, hey, you can use artificial ethene to cause the fruit to ripe faster. And then you're suddenly excited, oh yes, good. But why do you think the farmers want to do that? More crop yield, faster yield, okay, can. So you can actually say decrease waiting time for fruits to become ripened and decrease harvesting time. Can, okay? So you can say here, cause fruit to ripe faster, decrease harvesting time, increase yields in a shorter period of time. So these are all advantages or justification of why we agree to use artificial eating. So 1 mark comes from agreeing, and 2 more marks based on justification lah. So your reasoning must be logical lah. Okay, your reasoning must be logical. In this case here, there's no fixed answer to say that, okay, you must answer definitely this question. No, no, no. You can actually choose logical answers to answer in this case. So for example, it makes sense if I were to use artificial eating, the fruits will ripe faster, right? So that's the first justification already. It makes sense. It's logical. So therefore, I'll definitely get marks for the first point, right? And of course, if I can increase, if I can reduce the time taken for the fruits to ripe, then my harvesting time has been shortened. I can harvest earlier compared to last time. Normally, naturally, I can take, maybe like for example, the fruit takes around 2 months to be produced and to ripe completely. But then if I were to use artificial eating, once the fruit is produced, I can cut short by 1 or 2 weeks, for example. Then therefore, I will have more fruits in a shorter period of time. So that will also be logical in the case, right? And of course, like I said, increase the yield in a shorter period of time means I can get more plants, more fruits in lesser amount of time, so I can maximize my profit. So that's what farmers usually think lah. Okay. Now, then this is for farmers' perspective or businessman perspective, right? So now, as a scientist perspective, maybe for example, or a person who is more of a skeptic, then of course you will say, I disagree. So if let's just say a person disagree, right? Any of you disagree, why? Why do you think the person actually disagree to use artificial eating? So if you disagree, you also get 1 mark already. The problem now is you must justify why you disagree. So this is another explanation. I shorten the shelf life Okay, shelf life means like how long we can store it before it spoils. You can say here, consumption may lead to vomiting. Vomiting or 2 T, let me just check here. 1 T, sorry. May lead to vomiting, okay, and diarrhea. So 2 points not enough lah. So got 3 marks in total. So therefore, you can just choose any of this answer to use as your main justification. So you got 2 justification, got 2 marks. Then you get 3 marks in total. That is done already. Okay, so section C, 20 marks. Answer all questions in this section. So number 11, diagram 11.1 shows the structural formula of ethanoic acid. So here, state the basicity of ethanoic acid and explain. So ethanoic acid is a monoprotic acid. You get 1 mark already if you explain that. Okay. To explain the explanation here, you must explain that when ethanoic acid were to dissolve in water, it dissociates or ionizes to produce only 1 hydrogen ion per molecule. That's your justification. Okay, so you say over here, when ethanoic acid Okay, when ethanoic acid dissolves in water, so right over here, because too small space there. Okay. If you want to write the chemical equation, also can, although you won't get marks for it. So CH3COH, you put a reversible arrow with the water on top, and then you have ethanoate ion and one hydrogen ion. So it looks like that. Okay. Okay, next, experiment 1 and 2. So we can see here in direct 11.2, right? They have the balloon over here. And then what happens is that they put a glacial ethanoic acid together with calcium carbonate chips. On the right side, it will be ethanoic acid solution with calcium carbonate chips. So you can see that the balloon did not inflate. This one inflated. So if you don't know what glacial ethanoic acid is, glacial ethanoic acid is ethanoic acid without water. It's dehydrated already. Okay. So in this case right now, we are actually referring to the properties of water to show the properties of acid and bases. So based on 11.2, explain the differences in observation between experiment 1 and 2. You have to explain in terms of why the diagram on the left side did not produce any reaction, but on the right side got law. So you must explain that in order for it to react, it must be able to produce hydrogen ions. Okay. You can talk about the state of matter of the both substances here on the left and the right side. So the first one, you have to explain the differences in observation. So for diagram, okay, for experiment 1, experiment 1. What you notice is that the balloon did not inflate. Okay, then you explain that no carbon dioxide gas is released. And then explain why. You can say that in glacial ethanoic acid, the acid remains in molecule form or remain as molecule. Okay, or you say no hydrogen ions are present. And then for experiment 2, you must also be able to explain it's just 3 marks, okay? So you must make comparison. So you must have 3 comparison marks. So you must write experiment 1 and 2, 1 and 2, 1 and 2. So you must have 3 points, but the 3 points must be comparison form. If you write only for experiment 1, but you're not talking about experiment 2, you don't get marks. You must be able to explain the situation by comparing both points. So for experiment 2, the balloon inflates. Then you must explain why. Why does it inflate? Because CO2 gas is released. Then you explain that in CH3COH solution, H plus ions are present to react with CaCO3. So if you were to do that, compare between experiment 1 and 2, you should be able to get 3 marks in total. Let's go to B. 11.3 shows a flow chart of reaction that occurs in salt X. So again, like I said, this kind of flow chart question very famous, and it's actually quite good in the sense that it shows you directly what is going on. So the whole question itself is very clear, no confusion. So X, what happens if you heat it up? It gets a black solid Y, and then brown gas is being released, and then oxygen gas is also produced. So two things to take note over here. Number one is a black solid. So in chemistry, in your syllabus SPM, right, there's only 2 black solids: copper oxide and also carbon, pure carbon powder. So therefore, I think this is most likely copper oxide already lah. So Y is supposed to be copper oxide. Now, brown gas itself got many lah. I think 2 examples I can give you would be bromine gas and also nitrogen dioxide. So I will assume that salt X is copper nitrate. So the brown gas here is actually nitrogen dioxide. And then of course the last one will be O2 lah. So since I already confirmed that the black solid Y is copper oxide, the brown gas Z is nitrogen dioxide. So the salt X over here should be copper to nitrate.
I assume it is bromine gas.
Cannot. Okay, can, but you think about this. Where does the bromine come from? Can it be copper bromide? And if it's so, copper bromide, does it actually decompose? That's the question, right? So we have to ask ourselves, let's just say brown gas Z, we can assume that it's bromine, for example. But then you ask yourself, if it's bromine means, then the solid must be what? It cannot be it cannot be copper plus oxygen plus bromine some more. It's a very weird combo, right? If you imagine now, copper oxide plus nitrogen dioxide makes sense because it could be copper nitrate. But imagine now it's copper oxide plus bromine. How are you going to combine all 3 different elements together into one? Right? Cannot, very hard to make out a particular compound. So most likely it is not bromine, it is more likely to be nitrogen dioxide. And because you actually know that some of the less reactive metals, less reactive metal nitrates, when they decompose, they release out oxygen gas as well. So therefore, this is most likely going to be copper nitrate. So based on the 11.3, salt X can be prepared by reaction between black solid Y and substance P. Identify salt X, black solid Y, brown gas Z, and name substance P. So we get 3 marks already because we already identify X, Y, and also Z. So you got 3 marks already. The question now is, if I want to prepare P, what can I use? So you ask yourself, what property does this copper oxide actually have? Right? How can we create copper nitrate by using copper oxide and this substance P? So copper oxide is actually basic in nature. Basic meaning it is actually alkaline. So if you were to react copper oxide with nitric acid, then you'll be able to get copper nitrate and also water. Okay, so this is the idea behind it. So therefore, substance P, the last part, will be nitric acid. Next. 9.4 grams of X salt is heated and produce substance Y, Z gas, and oxygen gas. Write the chemical equation for the reaction and then calculate the volume of Z gas produced at room conditions. Now, because you already identify all three substances, you can just use the original, you use the actual chemical formula instead of writing X, Y, and Z, if you know what I mean. Okay. So again, it is the same thing as the above. So you have copper 2 nitrate decomposing to produce copper oxide. Plus NO2 plus oxygen. Okay. So you already write the chemical equation already. Balance enough, good enough. So I got 2 marks over there. Balance chemical equation, 2 marks in total. All right, next. Then they ask you to calculate the volume of gas Z being produced. In this case, Z will be nitrogen dioxide. So for every 1 mole of copper nitrate, you get 2 moles of nitrogen dioxide. Okay. So what we can do right now is to get the number of moles of it. So right now, your copper nitrate is 9.4 grams. And they already give you, right, the molar mass of X is actually 188 grams per mole. So all you have to do is just to find out the number of mole of X. In this case, it's copper nitrate. Okay, so that'll be 9.4 divided by 188. So the answer is 0.05. Okay, so it's 0.05. Now, since for every 1 mole of copper nitrate, you get 2 moles of nitrogen dioxide. So right now, your number of mole of NO2 is double. Okay, so right now, number of mole of gas Z will be 0.05 mole times 2, so you'll get 0.1 mole for gas Z. Okay, then after that, what you do, you just multiply by molar volume, which is 24 dm³ per mole. So volume of gas Z will be 0.1 mole multiplied by 24 dm³. Your answer is 2.4 decimeter cube. C 11.4 shows an article about the usage of sulfuric acid in the process of metal mining. In metal mining, sulfuric acid is used to leach copper to oxide minerals. Copper will be extracted from copper 2 sulfate. Excess sulfuric acid needs to be treated before it is discharged as the waste from the factory. So by using your knowledge in chemical properties of acid, suggest a chemical substance used to treat waste and name the reaction involved. Include an ionic equation to represent the reaction occurred and describe a chemical test to verify the absence of the acid in the waste. A lot of things going on. Okay, now let's just take the first part. Okay, let's break it down. Now, you're supposed to suggest a chemical substance to do what? To treat the waste. What is the waste? The waste is an extra amount of acid in the inside, right? You can see here, excess sulfuric acid needs to be treated before it is discharged. So the excess substance that you want to remove off is actually the sulfuric acid. So you're supposed to suggest a chemical substance which can use to treat the waste substance. So what are you going to use? It doesn't matter what you're going to use. You can use anything that you like, right? For example, you can choose to use calcium carbonate, or you can also choose to use any bases such as calcium hydroxide. Okay, technically any bases can be used now, but I have a feeling if this question comes up, it's not going to be like that. It's going to be more towards application. For example, how can we treat acidic soil? Okay, remember how to treat acidic soil. So if acidic soil were to be the case, we would not want to use things like potassium hydroxide or sodium hydroxide. Why? Too basic, too strong. So if you were to put that in excess, if all the acid has been neutralized, what happens? Then you have leftover bases, which now makes the soil even more alkaline, right? But if you were to use calcium carbonate, for example, it doesn't matter. If you have too much of it, it will not affect the pH of the soil because calcium carbonate is already a salt by itself. Neutral property. You understand? So right now, let's take a look at this. So you can suggest any of these substances, calcium carbonate, calcium hydroxide, or any base because the base itself is theoretically possible to be used to neutralize the acid. So it's describe one chemical substance done already, you get 1 mark already. Okay. Second one, they ask you to name the reaction involved. So if you use a base and try to neutralize the acidity of the sulfuric acid, then this particular name of reaction will be neutralization. Okay, neutralization is your answer. So you get your second point done. Then include an ionic equation to represent the reaction that occurred and describe a chemical test. Okay, now assuming if we use a base to make your life easier, all right, which means I can use either OH, calcium hydroxide, I can use sodium hydroxide, calcium hydroxide, anything lah, okay? So your ionic equation is very simple. Regardless of any case, right? Regardless of anything that you use, the ionic equation for neutralization is always the same. It's H plus OH minus, you get H2O, that's it. All right, very straightforward, very easy. As long as you see the word neutralization and they ask you for ionic equation, it's this. All right, it's H plus OH minus, you get H2O. Okay, done. 3 marks down already. Then after that, they want you to describe a chemical test to test and verify the absence of the acid. So what can we do to test for acidity? So of course, a simple one will be using, what's it called? Is to use litmus paper, moist litmus paper, moist blue litmus paper. Then you will not be able to turn to red. As long as it doesn't turn to red, then you know that it is not acidic anymore. So that's the test you can use. Moist blue litmus paper. And the outcome will be, does not change color.